want to talk about, summarily, set theory. There is no way you will not have this topic again reflecting in your exam. But we want to look at one aspect of set theory in which is a word problem, and you are now illustrating it first in diagram. The diagram for set theory is called what? Venn diagram. You have about 2 distinct types of diagram you will need to look at. I will even say 3, because the second one can be subdivided into 2, depending on the type of question given to you. In Venn diagram under set theory, you have the 2 subsets Venn diagram, and you have the 3 subsets Venn diagram. The 3 subset Venn diagram can be either drawn this way, of course, where the three subsets is actually intersecting. They have a common element, a common place of intersection. It could also come this way. In this situation, it is also 3 subsets, but the 3 of them are not actually what? Intersecting. All right. So what determines the type of diagram you draw is actually the information given to us. It will help us to review this topic by looking at 1 or 2 questions on set theory. It will also take us back to, I will take my time to take us back to what an intersection of a set is, what a union is. If you have 3 subsets, if you are talking about A intersection B union C, what is the interpretation? If you are talking about A intersection B intersection C, if you are talking about the cardinality of a set, what does it mean? If you are talking about writing element out for a particular set or subset, what are the things you need to be careful of in writing your answers out? Creating this background, you need to write my first example so that we can use that as setting the ball rolling for set theory. Can we write the first question? In a class of 31 students, 16 play football, 12 play table tennis. In a class of 31 students, 16 play football, 12 play table tennis, and 5 play both games. Full stop. Find the number of students who play. Find the number of students who play 1. At least one of the games. 2. None of the games. Find the number of students who play at least one of the games. 2. None of the games. None of the games. Okay. This is, how many subsets do we have in this question? How many subsets? Thank you, 2. And they are? Wonderful. Football and table tennis. Okay, let's illustrate the information in a diagram. And the diagram we are drawing now is a Venn diagram. It's called a Venn diagram. So this is our example. Example what? Example 1. The universal set of that question is what? 31. Meanwhile, number that play football is what?
16.
Universal set can also be, for emphasis, universal set can also be taking this, written as this, depending on what you prefer. Then, number of football is what?
16.
Number play, the next game is what? Table tennis is what? 12. Number play both.
5.
That is football and table tennis, 5. What the end between football and table tennis is called what? Intersection. Thank you, intersection. Okay, I want to turn that into diagram. I have two subsets, as you said. This is representing the first subset. This is representing the second subset. Knowing fully well that they told us they are intersecting, so these two circles must have a place of intersecting with each other. The universal set is 31. You have to show that on your Venn diagram. The first subset is football, and it is equal to 16. The second subset is equal to 12. The intersection is 5. After placing your intersection, it is clear that you will need to check now that if the intersection is 5, the remaining part of this circle should be 16 minus 5, that's 11. Are we still together?
Yes, sir.
Looking at this circle, the remaining part of the circle here should be 7. That's 12 minus 5. Because the total circle is what? Total circle here is what? 16. Naturally, this diagram should have been left this way. But the question has been asked is also giving me another signal that there is something else I have not included. What is it? Let's check the question.
Find the number of students who play at least one of the games.
Thank you. The first one is saying at least one of the games. Okay? Yes? None of the games. None of the games. How do we interpret none of the games? None of the games here is a signal that there is still possibility of having some students inside this box, but they will never be found in these two circles. That means I have a student outside. I don't know them, but I can represent that student with X. And that is when my diagram is complete. That's when my diagram is complete. Are we on the same page?
Yes, sir.
Great. So, with this, I can now turn this diagram into a simple equation. I can say my universal set, which is 31, is the same thing as 11 plus 5 plus 7 plus x. Because the universal set is representing the total number of students, and I can also say the total number of students is all those people that are having these activities added with the number of students that has nothing to do with the two games, but they are also students. They are students, but they don't like game. But because they are students, they must be added to the number of what? Students. Okay? With that, I have 31 is equal to what? This implies that x is equal to 31 minus 23. X is equal to what? 8 students. Thank you. And I've emphasized that when we are writing answers under set theory problems, don't just write the number. Let your examiner know what you are talking about. If it is bottles, please put bottles. If it is balls, put balls. If it is biscuits, put biscuits. If it is, what else now? Pen, thank you. What else? Soap. Bag. I know you like bag. This is a girl that said bag just now. The girls like bag very well. And shoes. Why did you say shoes? There was a question we talked about shoes and what? Bag. So we must, where am I going? We must be in tune with the question in a way that you don't just write the number alone. Please put whatsoever you are dealing with so that the examiner will know you are talking about what the question is actually saying. All right, that's 8. Can I now answer the question? They said we want to find those people that play at least one of the games. What does at least mean? At least means that the minimum you are considering that is the people that play or the students that play only one game. Minimum of one game. But you can consider anything above. But it must not be less than 1. So can we look at those students? So I want to say number of at least now. One game, Abby? Okay? So we have what? This is one game. 11, thank you. This 11 represents what? Football only. 7 represents what? Okay? So if it is one game, you can say 11 plus 7, at least one game. We started from 1. The next thing is 2 games. The next thing is, that's all. Are we adding X? Why are we not adding X? X, number of students that do not play any of, so it is from 1 and above. All right, let me change that question. It is not part of what the question is asking us, but I think we need to stretch our minds to, if the question turns around and say, at most, one game. You know I will not want that. At most, one game. Can somebody from my audience interpret at most one game? At most one game. Okay. My friend again. Okay, I'll give you a chance. Yes. The maximum should be 1, yes? So you can still consider people that do not, has not played or that are not playing any game. Hello, did you hear what he just said? Please appreciate that guy for me, powerfully. Thank you. He said the maximum should be 1. That is, you are considering only those, the maximum place you are starting from is people that play only one game, but you can come lower. That shows that there is possibility of looking at those people that did not play any. So for this, for at most, even though it's not part of the question, but it can come your way, at most, one game will be 11 plus 7 plus what? 8 is those people that did not play at all. Thank you. And this is what? 26 what? Thank you. 26 students. This one should be what? Are we still on the same page? Yes. Great. The next question there is none of the games. It's clear now. None is what? X, which is 8 students. at least that solved that problem. Please, can we quickly write, and we can take our next example. Let's quickly write. That's a good one. Are we set? Yes, class, are we set? Yes, sir. Okay, example 2. A number of students were interviewed to find out which of the sporting activities they liked. A number of students were interviewed. A number of students were interviewed to find out which of the sporting activities they liked. Open a bracket, football, comma, boxing, and volleyball. Football, comma, boxing, and volleyball. Students, they said football, comma, boxing, and what? So boxing is part of sporting activities. That looks very interesting. Boxing is part of sporting activities. Okay. They have 3 boxing activities now. Of course, football, comma, boxing, and volleyball. Are we done? Yes, sir. Great. 70% of those interviewed liked football. 70% of those interviewed liked football. Comma, 60% boxing, and 45% volleyball. 60% boxing, that's quite high. And 45% volleyball. Full stop. 45% like football and boxing. 45% like football and boxing. Comma, are we good? Some people are not answering me. Are we good? Yes, great. 15% boxing and volleyball. 15% boxing and volleyball. Comma, 25% football and volleyball. 25% football and volleyball. 5% like all 3 sports. 5% like all 3 sports. And X% did not like any of the 3 sports. And X% did not like any of the 3 sports. Are we okay? Are we okay? 1, draw a Venn diagram to illustrate this information. Draw a Venn diagram to illustrate this information. Draw a Venn diagram to illustrate this information. 2, use the diagram to find the percentage of students who liked. Use the diagram to find the percentage of students who liked 1. Let's take draw a Venn diagram as A. Then B, use the diagram to find the percentage of students who liked B1 now. B1, football and volleyball, but not boxing. Football and volleyball, but not boxing. 2, exactly 2 sports. Exactly 2 sports, that is B2, exactly 2 sports. B3, none of the 3 sports. None of the 3 sports. None of the 3 sports. Are we good? Yes. I'm not getting the yes. Are we good? Yes, sir. Okay. We need to read this question carefully. This is another question that is reflecting 3 subsets, right?
Yes, sir.
And that is our example 2. It's reflecting 3 subset problem under set theory. Can my reader read from that end?
A number of students were interviewed to find out which of the sports activities they like. Football, boxing, volleyball.
Okay.
70% of those interviewed like football.
So for football, I'll put 70%.
60% boxing.
For boxing, 60%.
And 45% volleyball.
For volleyball, 45%.
45% like football and boxing.
Football intersection boxing. Football intersection boxing. You said 45?
Yes, sir.
Yes?
15% boxing and volleyball.
Boxing intersection volleyball, 15%.
25% football and volleyball.
Football intersection volleyball, right?
Yes, sir.
25%.
5% like all sports.
5% like none. Okay, 5. Like all. That is football intersection boxing intersection volleyball, 5%.
X% did not like any of the sports.
That is football, union, boxing, union, volleyball, complement is equal to X%. You understand what I'm saying? Yeah?
A drawn a Venn diagram to illustrate this.
Because we are saying there's something that is outside the combination of everything, that X is outside. So that means it must be football, union, boxing, union, volleyball, complement. The complement of a set. Sorry, I'm using a term now. Let's remind ourselves of that term. What is the complement of a set? If I say my universal set is 1 to 10, and I can call on you anytime, so your mind should be here because I want to check again. Are you sure you still remember what I mean by complement of a set? And that is why I want to give this analogy. If I say my universal set is numbers from 1 to 10, and a subset of that universal set A is 1, 2, 3, 4, 5. 1, 2, 1, 2, 3. 1, 2, 3. The subset A of that universal set is 1, 2, 3. What is A complement? What is A complement? What is A complement? Who is talking to me? I can see some ants. What is A complement? I want to see faces that have not spoken to me today. Oh, okay, let me come from your end, madam. Yes, what's A complement? 4, 5, 6, 7, 8, 9, 10. Okay, without explaining that to me, please appreciate her. From what she said, maybe I can now create a statement. She has just told us that the complement of a set are the elements that are in the universal set, but they are not for that particular set. So if I say A complement, it is the element I can find in the universal set, but I cannot find them in A, set A. And that's a good one, because they will not ask you to define complement for them All they want to see is, do you understand that sign of complement? It can be A prime. It can also be A what? C. It can be A prime or A what? C. So, please, if they change, if your examiner changes it from prime to C, they are still saying the same thing, and we should solve it the same way. This is the information given to us. Yes or no, madam?
Yes, sir.
Great. So, can we use, they said, illustrate this information in what? In a Venn diagram. If you look at this question, we were not given universal set. We were not given expressly. But the question is talking in percentage, right? The question is talking in percentage. When a question comes your way and is talking in percentage, it shows universal set, which is the total, is 100%. And the question most of the time will be silent about universal set. They want us to use our common sense. If I say, Shola got 70% in a particular test, what is the total mark for that test? 100. 100. So, should you be asking what is the total number or total universal set when they have already said all these values are in percentage? No. You should let your examiner know that your universal set is coming out as 100%. The first subset, the second one, and obviously the third one. I have football, I have boxing, and volleyball. Football is 70. And I've seen students write that 70 here. Why is this 70 wrong? I don't want correct answer. I want somebody to tell us, because now we are interpreting this question. You will likely have a word problem on set theory this year in your exam. It's a very likely thing that is coming your way. So, well, it's my reader that want to answer that. Okay, I'll give you a chance. Okay, the question did not say?
70 football only.
Okay, but the question said 70% is football. So there is difference between, you are telling us now that there is difference between football and football only. Can we appreciate her for me, please? That position is football only. She's bringing something very good into play now. There's a difference between football and football only. What is the difference? If I say, students that play football, stand up. I've given myself room to have some other students that will join those people that are standing up. Even if they play some other games, they will still stand up. Because I did not say students that play football only. I said students that play football. So people that are standing may likely be playing some other games. In your question, please check. Do they put only in what I'm interpreting, or there is no only? And because there is no only here, this will not come here at all. It should be representing the total circle of football. The same thing here, total circle of basketball, of boxing is 60. Then volleyball is what? Are we there together? Volleyball is what? 45. Okay. They said the 3 is what? 5. Please, another important thing, you can see where I started from. I jumped all other intersection. I went straight to the 3 intersection. Before you think about the 2 intersection at all, you must first of all fix in your what? The 3 intersection. Because the 3 intersection will affect other 2 intersections. Am I communicating? Yes. When you fix this first, there is every likelihood that you fix a wrong thing. Can we look at that now? Now, if you look at this place cannot be 45. Yes. I'm getting 45. It cannot be 45. Why? Because football and boxing is this. Look at your diagram very well. You will agree with me that is football intersection boxing. Yes or no? Yes, sir. But out of the intersection, something has been cut off. What is it? 5. And they said football intersection boxing is 45. So if the total is 45, this way should be 40. Please, have I communicated? Yes, sir. The same thing, looking at boxing intersection volleyball. Boxing, volleyball. This is boxing, volleyball. You will agree with me? Okay? They said boxing and volleyball is 15. But out of the circle of boxing and volleyball, 5 is already taken off. This will be 10. The last one is football intersection what? This is football. Shay? Great. Out of football and intersection volleyball, which is 25, 5 is already taken off. This will be 20. Please, have I communicated? Yes, sir. What we are doing is very important. As soon as you get that stressed out, get that fixed up, you cannot miss it again. All right. They said there is something outside. That is what? X. What is it? It is those people that did not play any of the, but they are still part of the students. So they should be inside the box, but it cannot be inside the circles. Am I communicating? Yes, if this place is 25 and 40, I can get the remaining because I know the total. Can we do the simple arithmetic? This is 45 plus 20, 65. The remaining should be 5. Can we do simple arithmetic here? 45 plus 10. The remaining is 5 because the total is 60. Here also 35, 10. Great. So we have been able to complete the Venn diagram illustrating all that is given to us in this diagram. Are we on the same page, class? Yes, sir. With that, we can now look at what exactly is the question asking us to do. It said, use the Venn diagram to find the percentage of students who liked 1, football and volleyball, but not boxing. What is the other name for football and volleyball, but not boxing? Can somebody give us another statement that can be used for football and volleyball, but not boxing? Yes. Yes. Football and volleyball what? Very good one. Football and volleyball only. It's the same thing as football and volleyball, but not, because he's saying he's playing the 2 games only. He's not involved in boxing at all. Whether the girl or the boy, I don't know if it is a mixed school, but the girl or the boy just don't want to involve herself or himself in boxing. I think I started with that. I said, come on, boxing is part of the game. So it's a game. I don't know. But if it is a game, this boy is saying, I don't want to have anything to do with boxing. So he must be talking about football and what? Volleyball only. How do we identify football and volleyball only? You go to football and volleyball. This is football. This is what? Volleyball. Football and volleyball. Where is the intersection? This is the intersection. Right? But in the football and volleyball, we want to pick where it's not intersecting with boxing. This is boxing. Out of this circle, you will see clearly that in football and volleyball, something is not, this is what? Boxing. So you must cut off boxing. What is remaining? That is your answer. So football, intersection, volleyball, intersection volleyball, intersection what? Thank you, B complement. B complement. Is what? 20 what? The next question. Exactly 2 sports. Exactly 2, that is, exactly means what? No, exactly means what? That particular, okay? So exactly 2 means those particular 2 games. So it must be either football and boxing only, or boxing and volleyball only, or football and volleyball only. So football and boxing, 40 only, right? Boxing and volleyball only, 10. Share? Then football and volleyball only. Total. 70 what? Oh, thank you. We are working in percentage, so this should be 20% and 70%. Yeah, we are working in percentage. Yes? None of the 3 sports. And that is X. But you need to calculate the value of X. How do we calculate the value of X? We know that 100 plus, 100 should be equal to all the addition of what you have inside the circle plus X, that because it is also part of the students that are involved. Okay? So can we take it 5 plus 40 plus 5 plus 20 plus 5 plus 10 plus 10 plus X. We have 100 is equal to what? 95. This implies that X is equal to 100 minus 95, and that is 5%. Any other question? Okay. If I add one question to it, let's see your interpretation for this. Number of students or percentage of students who liked at least 2 games. At least 2 games. At least 2 games. At least 2 games. Let's see someone that can help us interpret that, because we have done something like that in the first example, so it should be easy for you. At least 2 games. Somebody saying 75. That's the final answer? Yes, sir. Okay, let's see how you got 75%. At least 2 games means minimum of 2. We can consider 2 and above. So we can consider 3. So 2 now will be 40 plus 20 plus 10 plus 5. And that is, thank you, 75%. Can you appreciate yourself this morning? Great. That's a good one. That also shows the end to our second example. I would like to give this question as an assignment so you can give me feedback in our next class. So can we write quickly as we get this session to an end? A selection interview was conducted. A selection interview was conducted for 110 students into various subjects in science department. A selection interview was conducted for 110 students into various subjects in a science department. Full stop. 25 was selected for physics. 25 was selected for physics. 45 for biology and 48 for mathematics. 25 was selected for physics, 45 for biology and 48 for mathematics. Full stop. 10 was selected for physics and mathematics. Physics and mathematics. 8 for biology and mathematics. 8 for biology and mathematics. And 6 for physics and biology. 10 was selected for physics and mathematics. Are we good? Yes, okay, I'll reroll now. A selection interview was conducted for 110 students into various subjects in a science department. Are you good with that? Yes, sir. 25 was selected for physics. 25 was selected for physics. 45 for biology. And 48 for mathematics. 45 for biology and 48 for mathematics. Full stop. 10 was selected for physics and mathematics. 10 was selected for physics and mathematics, 8 for biology and mathematics. 8 for biology and mathematics. And 6 for physics and biology. 6 for physics and biology. Are we good? Great. Why 5 was selected for all the 3 subjects? 5 was selected for all the 3 subjects. 1, illustrate the information on a Venn diagram. Illustrate the information on a Venn diagram. 2, how many students were selected for biology, but neither physics nor mathematics? How many students were selected for biology, but neither physics nor mathematics? Are we okay? Number 1 is illustrate the information on a Venn diagram. I want your attention to be here, and that's the last time I will read. 2, how many students were selected for biology, but neither physics nor mathematics? 3, how many students were not selected for any of the 3 subjects? Interesting. How many students were not selected for any of the 3 subjects? What does that mean? Lift your head up. Come on. What does that mean? How many students were not selected for any of the 3 subjects? For any of the 3 subjects. The 3 subjects are what? Physics, mathematics, biology. How many students were what? They were not selected. It can also be presented as physics, union math, union biology, complement. Complement. Thank you. Complement. The second question says that how many students were selected for biology, but neither physics nor mathematics. What does that mean? Interesting. Appreciate yourself again. Come on, powerfully. That's a good one. So, what you need now to deal with that question is what? A right diagram. You must be able, your interpretation is perfect. From my end, I'm giving 100%. Perfect. So you understand the question. You must be ready and be vigilant enough to translate that question into the right diagram. At this junction, I will need to take a pause. While this presentation will continue next class, but I want to appreciate my audience, and can you just please appreciate yourself for a very good presentation today. You have actually done well. Thank you for listening, and God bless.